Where am I? Where am I? Who are you guys? Who are you?
Hello, Department of Meeting Attendance, Integration and Compliance.
EEMT5220.
You are here because we noticed you have a problem, and we are here to fix it.
What's wrong? What's the problem? Oh, sorry, I'm late again. Again. Hey guys, I'm late. Oh. Sorry guys, it's raining outside. That's why I'm late.
Oh.
You're lying.
Hey guys, let's stop.
Actually, why you always late?
It takes too long time to get the meal.
Oh, it's certainly a problem. Let's see what can we do for you.
Okay.
When KK gets hungry, he has to make the first decision how to get to the canteen. He can choose to take a lift, which often involves waiting in a long queue, or go straight to the escalators or stairs. When he arrives at the GRB menu board, he makes the second decision whether to place an order or not. If he decides to order his food, he then proceeds to the food pickup area, waits for his food, picks it up, and then walks to a separate drink pickup area where he waits in a queue to pick up his drink, and finally starts looking for a seat. However, when he decides not to order a GRB, he walks to the APC menu board, places his order at the counter, and proceeds to a common food and drink pickup area to wait and receive his order and find a seat to enjoy his meal.
We should ensure that the measurement system is acceptable before the data obtaining. Thus, we need to do an analysis on our measurement system. 3 operators measured 2 parts of data, and we can see the significance of gauge error (ANOVA) in our measurement. As we can see, the effect of repeatability is much bigger than the reproducibility. Furthermore, we can see the total gauge R&R is 7.099%. Since the value is smaller than 10%, the measurement system is available. In order to identify main reasons that cause a long time for a meal, we set up a fishbone diagram for investigation. The analyzed symptom is that it takes too long to finish the meal. The first consideration for possible cause is that going to the canteen at peak hour, including the hours before and after lectures, breaking hours between lectures and school opening dates when there are a lot of visitors coming to campus. Another factor to contribute to the total time is the restaurant operation. When we look at the typical process that one get his meal at the canteen, we see that people usually get hesitated in front of the menu. Only if when they decide what to order they will continuously spend time placing orders at the counter. Then they will go to different counters to collect their meal and drink. In some situation there some people skip the queues, and meal preparation within kitchen also cause some delay. 2 canteen located in LG7 of HKUST take some time to be reached when students departure from the library. Students usually take neither lift nor escalator to go downstairs. We also include several situations that could be happening in this phase into our consideration. Last but not least comes several very special circumstances that would impact the time to take the meal, including university close date, public holiday, typhoon influence, and analyze phase. We use one-way ANOVA to analyze our data. Here we just show the box plot and residual plot for each factor. First we investigate the factor of canteen. In our case, APC has a lower average mean than GRB, which means in normal case eating an APC can save more time. However, the fact that APC box range is nearly coincided with GRB's box range. which means there is a risk to get a meal with unexpected longer waiting time. We can see the interaction between canteen and time in the next part. The residual plot shows that the model can describe the case properly since the residual is kind of normal distributed. Next, we investigate the factor of transportation. As we can see, the average time of escalator is a little bit longer than lift. Also, the range of lift is quite large, which means the time of lift may be impacted by other factors. We can see the interaction in the improve phase. The residuals are kind of normally distributed, which means the model is acceptable. At last, we investigate the factor of the time we choose to get to LG7. The highest average time lasting is at 6 p.m. Also, if you go to the LG7 at 6:15, you might have a very good experience of short waiting time since the range is quite large and the lowest point is around 17 minutes. Start over at 5:45 p.m. can also reduce slightly your time, but the difference is small. The residual plot also shows that the model is acceptable.
The main effects plots for replicates. The mean time is shown from this graph, which is 24 minutes 20 seconds. 3 factors influence the result. The time start to have dinner has a greater effect than the 2 others. This indicates that the average dinner time increases from 5:45 to the peak at 6 o'clock. After 6:15 it decreased below the mean time. In addition, Golden Rice Bowl takes longer time than Asian Pacific. The transportation way does not affect too much on the result, however. Lift seems faster than escalator at all time. Interaction plot for replicates. At the rush hour 6 p.m., lift takes more time than escalator. At the same time, you will spend longer time if you chose Asian Pacific to get dinner. Otherwise, lift and Asian Pacific is smart choice compare with others.
Subgroup size is 10 units for each. In NP chart, all the points fall within limit. Cases a lower control limit, which are sample 3 and sample 5, are acceptable since the purpose is to shorten the total time. Each point in X-bar chart indicates the average total time in each sample. The expected time length is 17.532 minutes. Also, points also fall randomly within limit, meaning our approach contributes stable results. In small subgroup size cases, standard deviation can be replaced by range. It is realized that variation of measurements is acceptable. In conclusion, the best solution is to go there at 6:15 p.m. by lift and eat APC. Also, if you have to go there at 6 p.m. to shorten your time, GRB and escalator is your best choice. At last, the result in control phase shows that our best solution is stable and accurate.
Oh, I'm the first one.